All right, this video helps explain the second part of section 8.7 in finite math. So here's the part from the book. Let x be the random variable for the binomial distribution with n repeated trials, with p the probability of success and q the probability of failure. So this is the formula that we worked with before for the binomial distribution. But you can use the normal distribution to estimate this binomial distribution. The mean expected value, variance, and standard deviation of x is given by mean mu is n times p. So if we have n is equal to 600, so something's happening 600 times, like 600 at-bats for a Major League Baseball player, and the probability, we'll say just for number purposes, is 1/3. They have 1/3 of a chance of hitting it. Then you multiply those together, your expected value, or your mean for the season, would be 200 hits. So 1/3 times 600 is 200. So that's where that's coming from. Variance is n times p times q, and the standard deviation is the square root of the variance always. So that's the square root of n times p times q. Now this is important. The normal distribution provides a good estimate for the binomial distribution when n times p or n times q, and both np and nq are greater than or equal to 5. So that has to be true. So here's how we do this. Basically, we have this part right here is the binomial distribution, and the normal curve is put over the top of it. So you can see that they're pretty close to each other. So if we want to go from 3 to 7, that's including the bar 3 all the way to 7. And you notice that if we're going to estimate this, we have to go over to 7.5. And then here for 3, we have to go under to 2.5. So we're really going 2.5 to 7.5, and that's how we calculate that out. We got to find that area. Now, if we're just doing 3 to 7, then that's 4, 5, and 6. But really, see the 4 right there? It goes down to 3.5. So we're going to go from 3.5 to 6.5. So that's how we do that one. And so basically, we just go through here and do that plus and minus thing. Now, if we want to know the exact value at C right there, we go just up and down 1/2 from C and figure out those probabilities. But we have to know we have to compute the standard deviation and the expected value first before we go on. And then we just do the plus and minus 1/2. And when we're going between two numbers like this, then we go below 1/2 and above 1/2 from the two numbers like we talked about. And if we're just not equal to, we go up, below and above by 1/2 for those. And if we're just doing greater than, we have to be above it by 1/2, and then we go all the way to infinity. So this side over here is worth 50% or 0.5, and then this side over here is whatever we get from looking it up on the table once we calculate the z-score. And the same thing goes here. It's 50% on this side plus whatever this area is, but this is equal to, so we go below 1/2. All right, and then if we want to know less than, we would go x is less than c, so we'd actually go less than c by 1/2 and then count down this way. So that would be this whole side here is 50%. So this whole side here is 50%, and then we can calculate only this part right here from the table. Why is that not going? Oh, I get it. It's fine. Okay. Delete. So we can only look up this part on the table. Let me go to the highlighter tool here and highlight. So this part right here is what we can look up on the table. And it's symmetrical with this side over here. So we look up this yellow part and we subtract it from the 50% to get this part over here, that tail. And the same thing is here, but we go above by 0.5. Okay, so let's do one of these together. So the first thing we have to do is we have to calculate the expected value and the standard deviation. So this is given the Bernoulli experiment with n is 12 and p is 5, use the normal distribution to estimate. And these are all the same problems, so I'll just do one of them. I'm going to select the pen tool here and pen. Okay, so or mu is the expected value, and I'm still writing with the pen. There we go, clear that out. Okay, so mu is equal to n times p, so it's 12 times 0.5, and that would be equal to 6. So my expected value is 6. And then the standard deviation is equal to the square root of n, p, and q. So it's going to be n is 12, p is 0.5, and q would be the other part of it is 0.5. That's the square root of that. Okay, that's not so easy, so I bring up my calculator here. Get my calculator, turn it on, and click some buttons here. Second, square root. And we got 12 times by 0.5, and then times by 0.5 again. The 0.5, the multiplication didn't go in there, did it? Okay. And then 0.5 again. Enter. So we got 1.73. So that's equal to 1.73. Okay, so instead of doing 7, we have to do the probability between 6.5 and 7.5. So we got to do this. We got to do this between 6.5 because we got to go up to 7.5. That's the bar that we have to find. Okay. So if we want to know 7, I'm going to do this one right here. I got to go between these two because you got to go up and down a half from each of those. So let's see. We have to figure out the z-score here. So the z-score for 7.5 would be 7.5 minus 6 over 1.73. That's going to be my z-score for 7.5. I also need to know my z-score for 6.5, which would be 6.5 minus 6 over 1.73. So I have to calculate these two things. Okay, so we get 7.5 minus that would be 1.5. 1.5 divided by 1.73. And we get 0.87. So then I go to the table, 0.87. The table's in the back of the book, on the very last flap of the book. 0.87 is 3079. Okay. Oh, 3079. So that part right here is 0.3079, and that was 0.87, right? 0.87. Okay, now I got to figure out this one. Go back to the calculator. And we got 0.5 this time, divided by 1.73 equals 0.29. So then I go to here, 0.29, 0.29, go to the table, 1141. So this is 11.41. Okay. So the middle is expected value 6, so 7.5 would take me to that. And then from the center up it'd be 30%, from the center up it would be 11%. So I have to subtract these two to find the area between those. So it's 3079 and 1141. So we got 3079 minus 1141. It's just easier to subtract them without the decimal points. So 0.1938. So the answer to this one is 1938. That was a good year, right? Okay, forget that. So what I did is I subtracted those two because it's the area from this to this. And so this is the difference between those would be the range of area. So that's how you do that. So all these are the same. So this one you calculate 6.5 to 5.5. This one you calculate 8.5 to 7.5. So when it's equal to, you go plus or minus a half on each side. Okay, let's do another one. Okay, now we're going 6 to 10, or we can do 6 to 10 with equals. This one is not equal to, so we can do either one of them. Let's do A, but I'll show you what to do for this one here. So since this is equal to, we got to go above. So you're really doing 10.5, and then you go 5.5. So you go 5.5 to 10.5. Here, since it's above 6 and below 10, we're really doing 5.5 to 9.5. So you're on the underneath side of 10, and you're on the, oh, no, you're above, your x is greater than 6. So it'd be 6.5, my bad. 6.5. So you got to be on the top side of it because it says x is greater than 6. You're not at 6. You're going to be above 6 because you're greater. So it's 6.5, and then x is less than 10. So you got to go below. So it's going to be 9.5. Okay, so it's this idea back here when you're going between two things. Okay, so there's C, so I had to go on the positive up a half on C, and then D, I had to go below a half on D. So this is the one we're doing right here, this situation. Okay, and then this one would be 5.5 and 10.5. Okay, I got that straightened up. So now we need to know the same things we did before. So the expected value is N times P, so that would be 25 times 0.3. So that should be 7.5. So my expected value is 7.5, which is in the middle, isn't it? It's in the middle of the two things. Okay, so that means I have to go from 7.5 down to 6.5. That's going to be a negative answer, and then 7.5 up to 9.5, and then those two answers get added together. All right, so here we go. Oh, I also need a standard deviation. So standard deviation is the square root of N, P, and Q. So it's going to be 25, and then N, or no, P is 0.3, and then Q would be 0.7. All right, so I got to type that into the calculator, and so clear second square root 25 times 0.3 times 0.7 equals 2.29. Okay, so here we go. So my first z-score is equal to 6.5 minus 7.5 divided by 2.29. So that's -1 divided by 2.29. And that to figure out that answer. And that would be, I have a calculator off to the side here, which is a little faster for me to type in. negative 0.44. So this would be negative 0.44. I don't know why that red shows up like that. That's annoying. Negative 0.44. So that's that. I have to look at that z-score. My other z-score would be 9.5 minus 7.5. Divided by 2.29. So that's going to be 2 divided by 2.29. Yes. So off to the side here, 2 divided by 2.29. I'm doing a calculator off here on the side is 0.87. So we get 0.87. All right. Now I'm going to look those up on the table. So I go to my table here. 0.87 is 3079. 3079. So go back to here. 3079, 0.3079. Okay, so there's that one. And then there's this one here, 44. And 44 is right there, 17, 0, 0. Okay, so okay, so that's the probability there. Now, so here's what's going on. You got your bell-shaped curve here. Your expected value in the middle is 7.5, right? So 7.5. And then I just figured out this area here is 6.5. And that's the 17, right? Because that's your below. So the area in here is the 0.17. Then I'm going over here to 9.5, right? So it's a bigger area. And that area from here over to there is the 3079. So that's your 3079. So then these two areas, right, this area in here and this area in here need to be added together. So the addition of these two should be the answer. So if we add these two together, we get 0.4779. So that should be the answer to that one. How are we doing here for time? All right, so keep going. So here is like, here's the two where you're going less than 4, less than 9, and then these ones, then these ones here, you're going greater than the number. Okay, so these are kind of similar to each other. So I'll go ahead and explain both of them, and we'll go from there. Let's do B, greater than or equal to. So first of all, the expected value. The expected value is equal to expected value is mu, not n, and it's n, which is 30, times p, which is 0.4. All right, so that should be 12, right? 30 times by 0.4 is 12. So the expected value is 12. So the standard deviation is the square root of mu, which is, or not mu, but n, which is 30, and then 0.4, and 0.6 would be the q. Okay, so I'm typing this off camera. Second square root, 30 times 0.4 times by 0.6. 30 times by 0.4 times by 0.6 is 2.68. So my standard deviation is 2.68. Okay, so now we're going after this one right here. So it's greater than 14. Or equal to 14. So since it's that, I need to go below it. So I'm really doing 13.5. So 14.5 would not be it. It has to be equal to, so I have to go underneath the 14 and do the 13.5. So here's the picture of this. Get my bell-shaped curve, right? And I don't like that. Let me do it again. Something like this. So 12 is what we're expecting in the middle, and 14 is over here, right? So I want to know that area above 14. So this whole half is 50%. So what I'm going to calculate here is really this part right here. That's what the table will show me. So I'd have to take 50% minus this red area. So I'm going to do 50% minus that red area to give me this tail out here. Because the formula only goes, or the cable only goes from the center to here. The red part is what the table has. And so then half of the curve is 50%. So I'm going to do the 50% minus this red percentage, and that'll give me that above 14. Well, 13.5. Okay, so the z-score is z is equal to 13.5 minus 12 over 2.68. So that minus that is 1.5. Over the 2.68. So now I'm going to divide that on the calculator. 1.5 divided by 2.68 is 0.56. 0.56. So I need to look that up on the table. Just double checking my math here. Table 5.6 is right there. 21.23, 21.23, 21.23, 21.23, 21.23. So 21.23 is the area. That's this piece right here. 0.2123. I wrote 8. Why did I write 8? 21.23. Okay, but I don't want to know that answer. I want to know this tail. I want to know the probability of being above 14. So your expected value is 12, and you want to be above 14, or 13.5 in this case. So we got to do 50%, 0.5 minus 0.2123. So 0.5 minus 0.2123 is equal to 2877. So 0.2877. All right, so there's the answer to that one. Okay, I'm going to do another one. If you think you get it, then go ahead and try the problems, but I'm going to go ahead and do this next one here. And that is this one right here. Given the Bernoulli 18, probability 35%. Okay, so my expected value for this one would be mu is equal to 18 times 0.35. So we got 18 times by 0.35 is equal to 6.3. So my expected value is 6.3. Okay, so then I'm going to do, I don't know, let's do this one. I did an equal to one last time, right? So I'm going to do this one here. So here's my bell-shaped curve. Woo! And then the expected value is right there at 6.3. That's the mean, the expected value. And we want to go below 4. So 4 is here, right? So I want to know that probability. Well, I can't know that probability. I can only know this probability here, and then take this probability here and subtract it from 0.5 to get that probability. Okay, so I'm going below 4. So that means I can't be, I'm going to be 3.5, right? 4.5 would be above 4. If I want to say x is below 4, so 3.5 is what I'm using. So to figure out my z-score, I do 3.5 minus the expected value, which is this here, 6.3, over the standard deviation, which I have not calculated yet. So the standard deviation is equal to the square root of n, which is 18. Probability for is 35, and the probability against is 65. Okay, type that into the calculator. Second square root, 18 times 0.35 times by 0.65 is equal to 202. So it's equal to 202, so 2.02. So that'll give me my z-score, and I can get the green area from the table, and then I can subtract that to get that area there. Okay, so we got 3.5 minus 6.3 divided by 202. It's negative 1.39. Okay, 1.39. So that is what I'm going to look up on the table. But it's the other side over here, right? It's 1.39, which is the same area as negative 1.39. So 139, 4177, 4177, 4177, 4177. So that means this green area right here is 4177. Okay, so then I have to take that from 50% to get that tail right there. So the answer is equal to 0.5 minus 0.4177. Okay, so 0.5 minus 0.4177 is equal to about 8%. So the answer is 0.0823. And that's my answer for that one. Okay, so I think that pretty well explains the second part of this. In about 28 minutes. So there we go.